So now we'll go over cut features that are on the top or the bottom of the door, which is simply designated by what side of the door the machining will occur with this drop-down menu: bottom, top, hinge, and lock edge. This machine is incapable of jams, but other machines can machine jams. We've selected the top edge. All you do is simply define the feature that you want to cut and download it to the queue. And now it is ready to run. The door animation here shows you how to orient the door. We've selected the feature on the top of the door, so the door is going into the machine with the top towards the cutting head, again designated by the Kval logo being towards the top of the door. And we also have in the top feature, we have a lock reference. So that means the feature's referenced off the lock side of the door here. We can now load the door into the machine and show you how that is done. So you'll notice there's two secondary stops on this outboard table. The reason for those is for when we're machining top or bottom features, and it helps keep the door square to the head so that the depth of cut remains consistent from one side of the door to the other. And you'll notice there's two. The one on the operator right is for all your normal doors. The one on operator left is for doors that are narrower than 18 inches. And that's simply placed over here to make it easier for the operator to get the door up against the stop, so they don't have to lean over so far to get all the way over to here. So they do the same thing, it's just this one is for doors narrower than 18 inches. This is for anything 18 to 48. We'll now load the door in for a cut feature that's on the top of the door. It's a very similar process to features that are on the hinge or the lock side of the door. We just orient the door slightly differently. We'll extend the stop in the same way with the door stop button on the foot pedal. But in addition, it'll extend this outer stop out on the table, which is in line with the stop on the head. And this secondary stop out here helps keep the door square and helps keep it from twisting, so that the depth of the cut from side to side stays the same. And then we'll clamp the door in the same way and start the sequence in the same way. We will now begin the machining process. So I'll now demonstrate the door stop. This pops up, and this is physically attached to the head. So when you download a door, it will pre-position the head and position the door stop in a position that allows the machine to reach all of the cut features within the door. So next we'll be going over the tooling that's available on an EFX. Starting at the top, we have the two chisel blocks, and those are differentiated left and right, each of those having an upper and a lower chisel, and this allows for square cornering of latch plates and hinge pockets and any other feature that you desire to have square corners. The first router is the pre-drill router, which comes with a 532 drill bit, but can also be changed out for an 1/8 inch drill bit. The second router is the main plate router, which is standard rotation, 5/8 diameter, and can also be changed out for a 1/2 inch diameter. The third router down is a counter rotate, which spins counterclockwise, and this eliminates the need for a chip out block. So any cuts that are exiting the door don't have any chip out. The last router is the deep mortise, which comes with a 7/8 diameter and allows for bigger plunge pockets and deep mortise cuts. Down at the bottom, we have a 0-3 degree pivot cylinder, which shifts all the tooling from 0 and 3 degree to keep the depths of the cuts consistent when machining beveled and straight doors. Next, we'll be going over the servo axes on this machine. We have the Y-axis, which is the vertical axis of this feature, and it's moved up and down by this ball screw here. We have the Z-axis, which is in and out of the door, which is also moved on a ball screw with a servo motor. And down on the bottom, for left and right travel, we have the X-axis, which is on rack and pinion style, servo motor also, which goes into this gear head, which has a pinion gear attached to it, and it moves back and forth on this rack, this tooth rack here. Next, we'll be going over the face tooling and servos. Starting over here, we have a 5/8 diameter bit for your bigger cut features, and it's a router. We have in the middle a 1/4 inch drill bit, which could also be changed to a 5/16 for function drills, whatever best suits your needs. We also have a 3/8 router bit for smaller features and things that can't be cut by a 5/8 diameter bit. Over here, we have the Y-axis servo, which again is run on a ball screw, and that brings this whole assembly in to allow these tools to machine. And then here we have the Z-axis, which again is on a ball screw and brings this whole assembly up to bring the tools into a position where they can machine the door. The primary type of bearing used on this machine would be a ball rail bearing, as we see here, and they should have an accessible Zerk fitting that you can get a grease gun onto and lubricate regularly. We recommend that the lubrication cycle on this is every 200 hours of operation or so, and you just get the grease gun on the Zerk fitting and pump grease until you see clean grease coming out from the seal, and then wipe off any excess to prevent dust from collecting on the exposed grease, and it's ready to run. The second type of bearing commonly used on this machine is a ball screw nut, as we see here. Again, there's an accessible Zerk fitting, and as before, you'll just attach the grease gun and pump until you see clean grease coming out of the seal, and wipe that excess grease away to prevent dust from collecting and packing into the bearing. These need to be lubricated about every 80 hours of operation, as they see a lot of wear moving up and down and moving all the components around. The way that the rack and pinion is lubricated is through this auto lubricator here, and it has an internal piston that pushes grease through the canister and down this tube and actually lubricates the pinion itself. This is done all automatically, so anytime this axis is in motion, it's pushing grease through that tube slowly. There's an eye right here that when the level gets low, it will give you a warning on the operation screen notifying you that the lubrication level is low and this component needs to be replaced.